Hello, welcome back to Cracking the Cryptic, and it's Killer Sudoku today. I did a killer only recently, quarter through, Jeremy Butler. Now that was very different in presentation in the sense that it had no given digits and it had a remarkably few number of cages, in my opinion, for a killer Sudoku. This is more traditional, I think, by Austin C., whose debut I believe this is on the channel, and he's sent us this puzzle and believes it has some interesting features. So I'm looking forward to giving it a go, and at the very least it's going to be a practice for killer Sudoku. And if you really like to practice your killer Sudoku, get our Killer Sudoku app. It is amongst our suite of apps. You get 100 puzzles for $5.99 or something or less. And they're puzzles by some of the best constructors in the world and us. And it's just the best value in Sudoku, our apps. Although, actually, they compete with Patreon, which is very good value as well at $2 or $3 a month. So much extra content there. July's Puzzle Hunt is Blobs' unbelievable Lord of the Rings. And there's loads of other stuff on Patreon. It is well worth your time, well worth a bit of your money. Honestly, it just is. Give it a go. Anyway, that's in the links in the description field under the video, along with our merch and Sven's Sudoku pad, etc. Do check out the links. There's lots of ways to engage with the channel. We love it when people even just watch us. And so you can either try this puzzle first or watch me have a go at it. You can probably guess how long I'm beating my head against a brick wall by the video length, which I don't know yet because I haven't recorded the video. But I'm going to explain the rules. As I say, I think Austin C's a newcomer. And it's called Ring Cycle. The rules are that normal Sudoku rules apply. That's putting 1 to 9 in every row, every column, and every 3x3 box. And then within a cage, there are no repeat digits, and the digits sum to the total given. Those are the rules, regular killer Sudoku. So give it a try. I'm going to reset the clock and say, let's get cracking. And this central cage has to be 5, 6, 7, 8, 9. That's the only way that in 5 different digits you can make up a 35 total. And there's another 35 total on the right hand side. So that's 5, 6, 7, 8, 9 again, and the other digits in the column are 1, 2, and 4. In fact, in this 10 cage, the digits that aren't given are 1, 2, and 4. Oh, I've got a 16 cage with a 7 ruled out of the top cell, so I can just write in 9, 7 there. Then I've got a 5, 6, 8 triple as turned up in this box. Now, the 11 cage is 1, 2, 3, 5. Again, just like 10, it has to be 1, 2, 3, 4. There's only one way of making up 11 in 4 different digits, and that's it. And then by Sudoku, with that 5, 6, 8 ruled out of those cells, we know that this is 6, 8, this is 9, 7, 4, and the 7 cage is going to take the 4 of those. So we've got 9 and 7 in a 22 cage with a 6. That 6 means this is a 9, 5 pair, and that sorts out the 7 and 9. So this is a very approachable puzzle. That 5, 9 is now looking at the corner. I was wondering if these 4 corner cages were going to lead us to investigate the Fistamafel ring. Actually, that is quite plausibly deliberate. Don't know. Anyway, we won't do that until we have to. Now, this 15 cage doesn't have a 9 in it or a 6, so it's 8, 7. That's the order. This has 1, 2, 3, 4 in it. There's another 10 cage. This pair can't have a 9 in it from that 5, 9 and that 9. So it's a 6, 8 pair. This is a 4 to complete this column. So with just a few pairs left now, I'm going to put in a 1, 2, 3 triple there and a 5, 7, 9 triple down here. Now, what have we got going at the top? These add up to 10. They can't be 8-2, 7-3 or 9-1. So they are 6-4. And that's not a 4. In fact, it's not a 4 or a 2. That's a 1. This is the only place for 5 in the row. That's a 1. This is a 2-4 pair. These are a known set of 5, 8, 9. And this cage is adding to the right total, unsurprisingly. Another 1, 2, 3 set here to match that one. Down here, this 12 cage, 10 cage has in 4 cells has 1 version, as so does an 11. A 12 cage has 2. It's either 1, 2, 4, 5 or 1, 2, 3, 6. And I don't know the answer yet. Oh, we've got 1, 2, 3, 4 to place in the central box. Now I'm wondering about colouring low digits. We can't have an 8 in this 10 cage, but we must have a, no, not necessarily must have a 1 in it. We've got 5 or 6. That 4 cage doesn't have a 3 in it, does it? It's a 1, 2, sorry, this 7 cage with a 4 in it doesn't have a 3 in it. Now, can that be a 9? That would be a 1, that would be a 2. Not impossible yet. This 8 cage is either 1, 2, 5 or 1, 3, 4. I'm just going to fill in those candidates actually, because I'm just wondering about this group in box 9. Oh no, look, I can do secret maths. Right, I haven't yet officially shared with you the secret today. The secret is that Simon and I know the sum of every row, column and box in a Sudoku every time. Incredibly, it's always 45 because that's the sum of the digits from 1 to 9. So if we add 2 columns, we get 90. And then if we add the cages in these columns, we get 61, 73, 83. We deduct that from 90 and we write 7 into this remaining cell. So that's not a 7. And that's not a 7. That's not a 5. This isn't, oops, this isn't 7 or 8. That's not a 6. These pencil marks are getting slimmed down a little. Now, there has to be a 9 in this column somewhere, and it has to be in those 3 cells. So these can't have a 9 in, and the 9 in this final cage is there. Final column cage. And that puts a 5 into this 12 cage. We can't have a 5 there now. This is 1, 3 or 4. Right, how are we going to get this up to 12 now? Only by taking the maxima in that cell and that cell. So let's write them in, and we've made it work to 12. That's now a 1, 3 pair. In an 8 cage, you can work out the other digit. It's a 4. Those have become a 1, 2 pair. In the box, that means we have a 3, 4 pair. This isn't 3. Now, that can't be a 1 because there is definitely a 1 in the 12 cage. Now there is definitely not a 3 in the 12 cage, so it is a 1, 2, 4, 5 cage. And that's a 1, 2, 4, 5 triple, which I could probably have worked out more easily by deducing that this was a 9, 8, 6, 3 cage, which I'm sure could have been done a moment ago and I didn't do it. That means this is a 1, 2 pair. I think the Fistmafel ring is really packed with little digits, isn't it? Probably because, yeah, I mean, I can sort of see that the Fistmafel boxes, sorry, I haven't explained that there is a way you can prove, and I could do it easily enough, that these purple boxes must contain exactly the same digits as these yellow cells in the Fistmafel ring. And what I'm now looking at is the digits that aren't... Oh, actually, this is quite useful now. There's probably another useful way of doing it, but... Yes... Well, I don't know. Okay, let me just do the proof, first of all, then. Let's not make those yellow. Let's make all of these purple. Now, I'm doing the proof of the Fistmafel ring now. It won't take long. Those 4 columns must contain 4 sets of the digits 1 to 9 by rule. So that's what the purple contains. If we select box 4 and box 6 and row 3 and row 7, each of those entities must also, by rule, contain 4 sets of the digits 1 to 9. So both the yellow area and the purple area contain 4 sets of the digits 1 to 9. Now, if out of those 4 sets, we remove the cells in these highlighted, the digits in these highlighted cells, then what we will have left is exactly the same digits in yellow and purple. And that is why the Fistamaphel ring works. Now, what I have now noticed is that this is going to have to be a 5 because there is no 6 in the purple. There are 2 5s, one there and one there. In the yellow, there's 1 5 there. This now has to be a 5. And now we can maximize these digits. I mean, there may have been another way of getting there, but I'm prepared to use any way I find to solve a puzzle. It's just who I am. That 5 is looking at that. I don't know why black digits are harder to focus on than blue ones when you're solving. I just find it all the time. Those can't have a 9. That can't have a 6. That can't be 7 or 8. I've got a 1, 2 pair. I've got a 4 looking at that cell. There we go. Sudoku, always the easier thing to do when you can remember to do it. There's a black digit looking at something, so that runs around, and all the yellow digits in the Fistamaphel ring are done. I feel like I should know what these digits are. That's 8 or 9. This is 3, 6 or 8, and this is 6 or 9. I don't really understand why I don't know what they are, but I don't. I can do maths in the bottom 2 rows, perhaps. Let's try this. They add up to 90 because of the secret, 45 in each row. Let's subtract the cages. A 10 takes us down to 80, a 12 takes us down to 68, an 18 takes us down to 50, a 17 takes us down to 33. Let's take out the 7-9 pair, and we're left with 17 in these 2 highlighted cells. The only way to do them, even though they don't see each other, is 8 and 9, and this one must be the 8 in this column because there's a 9 in it already, and that must be a 9, and that is going to finish us off, I think. We get a 6 there. This needs 11 more that aren't 9, 2, 7, 4, or 6, 5, so they are 3, 8. This is a 5, 6, 7 triple, which determines where the 5 is in the bottom right cage. There we go, and that's a 2, that's a 1. That's the only place for 5 in the row. That's not 7, that's not 5, that's not 6. That's not 6 either. This is not 8. I think all of these need a bit of tidying up. That's not 5, that's not 9. Oh, come on, 9, 4, 2. There's a 3 in this row. The last 3 in the grid, easy to write in, easy for you to spot, not for me. Okay, I mean, we've got all the cages populated with the right digits. Oh, I've got an 8 looking at that. Yeah, that is a naked 7. It sees all the other high digits. Okay. Well, that's going to make quite a big difference. So that makes that a 5, sorts out the cage at the bottom. That sorts out the cage at the top. That sorts out the middle column and the middle row. And that finishes the puzzle. And not too difficult, but quite interesting. A good example of an approachable puzzle. And we even got to learn about the Fistamaphel ring while solving it. And there we go. That's good fun. So thank you to Austin C. Not too difficult. There was a lot of cages. I wonder if a couple could be removed and the puzzle still be solvable but more difficult. I don't know. I mean, I like straightforward puzzles. I do. They're fun to do and they satisfy you. I mean, I just like the buzz of solving puzzles honestly. So thank you for watching, as always. I assume you do. Otherwise, why are you here watching this? Or at least you like the buzz of someone solving puzzles. And in this case, that's me. So thank you for watching. And thank you to Austin C for sending this. We will be back with more tomorrow, and we really hope to see you then. Bye for now.